Good morning. This is Mr. Spensey, your stat sensei, and we're here to talk about paired data and specifically about the paired t distribution. But before we get into actually running paired t-tests, confidence intervals, I'd like to remind you that we've actually worked with paired data before. We worked with it at the very beginning of our year when we ran matched paired tests. All right, we matched pair designs. We actually designed the experiment. And one of the favorite ones of mine, just because it's evil and generally sadistic, was a mosquito experiment where we put one arm, we put the mosquito repellent on one arm, the mosquito repellent B on the other arm, and put each arm in a separate bin to see how many bites you would get on the arm. And then we'd compare the differences. And y'all, I'm sure you probably remember that because I just think it's a hilariously awful experiment seeing someone being all eaten up by mosquito bites. But the question is, why did we do that? Why did we test that person essentially twice? Why didn't I just say, hey, half of the people get mosquito spray A and the other half get mosquito spray B? Why did I spray someone twice? So they essentially got tested twice. And the reason we did that was to control for variation between the individuals. Because remember, some people are very susceptible to mosquito bites and get them really easily, and others do not. Okay, so to control for that individual variation, we did that. We also had the waterproof boot design. And in the waterproof boot design, there were one type of waterproofing on one shoe and the other on the other shoe to control for differences in the individual habit. So that's the way paired data arises, okay? And what we're looking for is typically, because there's several different ways it does arise, and we just need to make sure that we can identify it. Well, what we're going to be doing in these next several videos is that was the design of the experiment, is we learned how to design the experiment earlier in the year. And now that we've designed the experiment, we've carried out the experiment, we've collected the data, how do you analyze it? So that's what we're going to be learning. But first off, we need to go back and go, well, if someone gave me a data set, how would I recognize, in fact, that it really is a paired design? Well, one of the easiest things is to sit there and go, is an individual, in other words, is a subject, are they measured before and after treatment? So if they got measured twice. So another thing, if they sit there, if you go, you know what, the same thing or the same person got measured two different times, typically in a before and after situation, then it's going to be a paired design. And basically, remember we said we like running paired data experiments. Matter of fact, we prefer to run paired experiments when possible because we control for a lot of variation between individuals that we really couldn't design for otherwise. Now, there happens to be sometimes that pairing is slightly odd, all right? Well, the medical profession really likes twins. They'll give one twin one medication, the other twin the other medication, and compare the differences. And the reason they like doing it for twins is because they're biologically and genetically so similar that it controls for a lot of variation. Again, a paired t-test or a paired data experiment is trying to control for variation. We might look at spouses where the husband is compared to his wife, all right? The husband is compared directly to his wife, but please note that is a one-to-one matching, one husband to one wife. That is not looking, because we could look at the average of heights and go, hey, we could run a paired t-test or we could run a two sample, and they're different. A paired test would go, I'm going to look at my husband's height, and I'm going to look at the wife's height, and I'm going to subtract the difference. Whereas a two sample would take the average of all married men and subtract it from the average of the married women. So please remember, If you're working with spouses, make sure it's a one-to-one matching. We can do the same thing with siblings. A sister, measure a sister individually paired to her brother. But please remember, it has to be a one-to-one pairing in some form or fashion. And once again, the reason you might want to do it for siblings, even though they may be somewhat, first off, they're reasonably similar genetically, but also in a social, in a sociological standpoint, they grew up in the same household, so they have the same, generally the similar beliefs, and were nurtured or not nurtured in similar ways. But please remember, to be paired design, we need to have an individualized one-to-one matching. We're not comparing one group to another. It's a one-to-one matching. All right. Another thing to look for, if we have a list of data, the two samples will be the same length. All right. Now, just because they're the same length doesn't mean it's paired, but if it's not the same length, it's not paired data. All right. Because if you had a one-to-one matching, it's going to have to be the same data lengths. All right. A paired t-test looks at the difference between the paired values. So in other words, it'll measure the wife's height minus the husband's height, and then it'll do it for the next one. So it's looking at that one-to-one pairing and finding that difference. And then we run the t-test just like a one sample t-test using those differences. All right. The one thing that I would say is difficult about this is confusing whether or not it's a two sample t-test or a paired. And we haven't covered two sample tests yet. That'll be in about a week. And so we need to be very careful that we're actually working with paired data and recognizing that it's a one-to-one matching of some sort to create the pair. All right, the next videos I'm going to be running, we're going to be carrying out paired t-test and paired confidence intervals, and I hope you will join me for that. See you in the next video. Thanks.